In this video, we're going over the concepts for Lab 6, which is titled Chemical Reactions. This lab is a virtual lab assignment in which students are going to explore 4 different types of chemical reactions. I am first going to explain the background of the 4 different chemical reactions, and then I'm going to proceed to talk about the different components of the experimental procedure which needs to be performed in the OLAB's website. When it comes to chemical reactions, understand that there's several ways to classify them. But in this lab, you guys are going to be working with combination reactions, which are also known as synthesis, decomposition reactions, single replacement reactions, and lastly, double replacement reactions. Let's now discuss each of these 4 chemical reactions, starting with combination. As I mentioned, a combination reaction, which is also known as a synthesis reaction, is where we have 2 or more substances, which can be elements or compounds, that combine to form one more complex substance. If we talk about the general reaction, which we can label with letters, the 2 components that combine together can be labeled as A and B. And when they combine, they're going to make a single product, which is labeled AB. An example of a combination reaction is going to be the formation of water. You can see here how molecular hydrogen combines with molecular oxygen to make a water molecule. The coefficients that you see before the components of this reaction are utilized in order to have a balanced chemical equation. Remember that these coefficients are necessary so we have the same number of atoms in the reactants and in the products. The next type of reaction that you guys are going to be working with is a decomposition reaction. And a decomposition reaction, in essence, is going to be the opposite of a synthesis or combination reaction. In a decomposition reaction, we're going to have a compound that breaks down into 2 or more simpler substances. If we use the general form for this type of reaction, you can see that the compound AB is going to decompose into just A and just B. To illustrate this, we're going to have the following reaction. So a water molecule can be decomposed through the process of electrolysis into molecular hydrogen and molecular oxygen. The next type of reaction that we have is a single replacement reaction. In a single replacement reaction, we're going to have one substance in a compound that is replaced by another more active substance, which happens to be many times an element. When it comes to the general form of this reaction, if we have that more reactive element labeled A, when it is reacting with a compound BC, the single replacement or single displacement happens to be that A is going to replace B in the compound and it's going to make a brand new compound called AC. And we can see in this reaction that the letter B represents that element that was replaced or displaced as part of the reaction. To talk about an example of a single replacement reaction, we have zinc reacting with copper to sulfate. And we can see how zinc replaced the copper and we see it by itself in the product. And now that zinc in the product, we can see that it formed a new compound with the sulfate and we can see it as zinc sulfate. Lastly, we have double replacement reactions. And in double replacement reactions, the way that we mention them is how these compounds are going to be exchanging partners. So When we talk about general terms of a double replacement reaction, we have two ionic compounds, A and B, and C and D. The assumption is that A is a cation, B is an anion. Similarly, C is a cation, D is an anion. So when the metal ions of these two ionic compounds exchange, then what happens is that we form the compounds A and D and C and B. And if we look more closely, the cation A plus, when it combines with D minus being the anion, that's what gives rise to A and D. When the cation C plus has a new partner in B minus being the anion, that's where C and B comes from. To give an example of a double replacement reaction, here we have the reaction of silver nitrate, which is in aqueous form, reacting with sodium chloride, and it makes silver chloride and also sodium nitrate. Now, understand that in many double replacement reactions, in the majority of them, at times we can see the formation of a solid. And that solid, let me just highlight it. That solid that is formed, it is known as a precipitate. In chapter 9, we are going to learn how to predict which one of the components, if it happens to form a precipitate in a double replacement reaction, how do we actually determine how it's formed? As you go through the different examples in these type of reaction, you might notice, as I mentioned in our first example, that there are coefficients that are placed before elements, diatomic molecules, and even compounds in these reactions. And that is because it is essential that whenever we have a chemical reaction, we have the same number of atoms in the reactants and in the products. Having a balanced chemical equation is what allows, in the different laws that exist in the discipline of chemistry, means that we are able to respect the law of conservation of mass, which establishes that matter is not created out of nothing and is not destroyed into the world as like it disappears or goes away. That is keeping track of the atoms that we have overall in our chemical reactions. Remember that when we are balancing an equation, you cannot change the subscripts in a reaction. You cannot. The only thing that you can do is add those coefficients before the whole compounds to adjust the number of atoms that we have, again, such that we follow the law of conservation of mass and we have the same number of atoms in the reactants and in the products.